Hello guys, today I want to talk about how you could structure structure the system for an AI app. I want to talk about the front and the back end services that we are going to implement or that you need to implement, how you can communicate between those, how you can manage the integration of AI, and how you can communicate with your database or how you store your data. And that's everything I want to talk about today. So at first I am gonna create a frontend. We're gonna have the frontend application, which is how the user can access our app. So we're gonna have the frontend. The frontend is just the interface which is gonna communicate with the API. This is the next part of our application. We're gonna have an API, and that's the nice thing about the infrastructure. If you plan it, you can use whatever technology you want to use. The API can be written in Python. You can use Fast API, or you could use Express. You could also use Next.js, so you're gonna have the API directly in Next.js. Because it's a full stack framework, you can define your pages and your API directly in there. Alright. Those two are gonna communicate between. And I'm gonna synchronize this with these two arrows. Yeah. The frontend is gonna do requests to the API, which is gonna handle the logic. So we are gonna have a database, which can be Postgres or a NoSQL database. Alright, this is our database. The API is gonna query against the database, whatever is needed. We can do that. Alright, we're gonna get data from the database, and we are also writing into the database. For example, if a user is going to write something into the database, we need to store that. Of course, we also need the auth an auth provider. We can also do auth just in our application, but we probably want to use OAuth. So we're gonna have an auth provider which can be Google, for example. So I'm gonna add an auth provider. Alright, this is our auth provider. Whenever a user is going to sign in via an auth provider, we are going to request from the API, and we're going to request a redirect. So the API is going to communicate with the provider and going to give us a redirect. We are going to the redirect, and this is going to send a request back to our API, and this is going to grant us a token. So the auth provider is going to communicate with the API, and that's how we're gonna communicate via the API with the auth provider. Alright. If you want to know how this is going to work, you can research how OAuth works and how OAuth is implemented, but I'm not going to cover this in this video because this is just a basic overview about which technology or which you need or what do you need to think about if you're going to create an AI application. Alright. Another thing we need to think about is task queues and task management, because our AI app probably gonna have long-running tasks. If you're gonna integrate, for example, GPT and other large language models, you don't want to have them running on the main worker. You're going to have task queues, and you want to create tasks that are gonna get handled by another worker. So we're going to have a task queue. The task queue can be, if you are using Fast API, Celery could be used, or you can use Kafka or RabbitMQ. So this is also open for you to choose or what's gonna fit your needs. The task queue is going to handle all the tasks. So I'm just gonna do that. This task. So we have one generate task. Generate, and another generate task. Alright. Those are again handled by a worker. So we're going to have a worker which is just focusing on those applications. And will process everything. So we are creating a task from the API, and this is going to get shipped into the task queue and is going to get handled by the worker. And if we can, for example, if we want to create a post or something in the API, we're going to create an entry in the database which has an loading status, and we're gonna add whatever we create with the large language model to the database when the task is finished. So if the task is finished, we're going to write into the database whatever was the result of the task we ran. So we are going to write from a task into the database, and the worker is going to handle each of these tasks. So can connect that and that. The worker is going to handle those tasks. The same way, you will probably want to use a different task queue. You can handle emailing, so emails could also take a long time, so you don't need to have them run in a second, or it's fine if the email just arrives 1 minute later for example, for verification purposes. Yeah, you also, if you are running an AI app, you probably also want to handle payments. So can handle payments with Stripe, PayPal, or whatever payments. And you probably, if you handle payment, for example with Stripe, you're going to create a session on your API, and the user enters this windows, and the payment provider is going to access a webhook, so a callback on your API, and the callback is then going to do whatever your payment should do. So if you, for example, you subscribe to a service like a premium service, you're going to create a checkout window. The user is going to pay. This is going to trigger something on the payment provider side, and the payment provider is going to call an endpoint on our end, so a callback, and the callback then can change, for example, the subscription to premium. So the payment is going to talk to the API, and we're going to create a checkout from our API. Alright. Now we can also talk about front-end integration. That's something like that's up to you. You can use React or whatever. In the end, you can integrate it with the API, which can be a RESTful API, or you can use GraphQL. So everything is loosely coupled. That's really nice. The auth provider is also up to you. You can use OAuth, or you can use other auth providers. Like you can use an auth provider like Clerk or Kinde. There are a lot of options, or you can create your own auth provider. And we can also talk a bit about load balancing. Or scaling. Load balancing would be you have multiple instances of the API. So if you have a lot of requests, you can either increase the server capacity or the server resources of one instance, but you can also create multiple API instances. So you can have 1, 2, and we have a user or users, and instead of accessing one API, we are going to split the traffic between 2 APIs. The same, you can also scale the database. You are not only accessing one database, you can scale that horizontally. You can have multiple databases. The same for workers. You can have multiple workers, like you can have 3 or even more workers that are going to handle your tasks. So if you have a lot of tasks being generated, you can have more workers that are going to work on this task and finish them. Yeah, so I think that's a great overview for what you need what you need for your application. Later on, you can deploy those applications in a cluster or containerize your application, and can also integrate continuous integration, like you change something here, you're going to deploy this into a container. And yeah, so you can stay really independent from one cloud provider. You can just containerize your application like that and deploy it on Google Cloud or AWS Cloud. So it's really independent and it's really loosely coupled infrastructure. You can also about the database, like you can use an ORM, so that's even less coupled, or you can use the database driver directly, like the Postgres driver. You can directly access the Postgres database with this driver, or you use an ORM. Then you can use probably MySQL or Postgres with probably almost the same syntax. So I think it's a great structure for an AI app, but this is also not just for AI apps. Like if you have long-running tasks in an app which is gonna compute something, you can use the same infrastructure. So also the task can communicate with whatever large language model provider we're going to use. You can have OpenAI right here, and the task is going to talk to OpenAI, and OpenAI is gonna deliver the request, which is going to take time, and that's the reason we are going to put it into the task. We don't want to wait on the mainframe until OpenAI or whichever provider delivers us a response. So I think this is a great overview. Feel free to comment what you would change or how you would implement something, or if you have already implemented something like this. And I will see you in the next video.